Alright, hello my wonderful students. This is part 3 of foldable number 2. So for this one, we're going to be using quite a bit of different things to do this. So the table shows the world population of the Iberian lynx in 2003 and 2004. If this trend continues and the population is decreasing exponentially, how many lynx will there be, Iberian lynx will there be in 2014? So we're using this table here. This is the table shows. So it says the population in 2003 was 150, and in 2004 there's 120. So in order to do this, we have to set it up in the equation that we had before, which is the one we're using of a to the t is equal to a times 1 plus r to the t. We got to set up in this equation first before we can figure out the other stuff. So in order to do that, we have to first find, we have the information if we went from 2003 to 2004, and we have in the 1 year it went down this population here. So in order to do that, we have to basically find our rate. Well, our rate is going to be equal to the delta y over the original y. So if you guys remember, delta y was the change in y. Remember we had change in y over change in x for slope, or distance. So our delta y is going to be equal to our y2 minus our y1, and this is going to be over our original y. Okay, so our y2 is going to be 120 over, 120 minus our 150 over our 150. And this, the reason why we're doing that is because this is going to give you a ratio of what we lost. Okay, so if we do this, we're going to get a negative 30 over 150, which ends up equaling negative 0.2. Okay, now we can go ahead and submit that in for our r. So we have, let's go back to red. We have a to the t is equal to a times 1 plus negative 0.2 to the t. Okay, yeah, we'll get back to the t after. So 1 plus negative 0.2 is going to be equal to a to the 0.8 to the t. Well, I need to find my a. Actually, we know our initial at year 0, this is year 0, was 150. So if we change this to 0 here, we have that 150 is equal to a to the 0.8 to the 0, because it's year 0, and 0.8 to the 0 is going to be 1, so this is going to be 150 is equal to a. So we're getting everything kind of set up. All right, so now we have our thing, so we can do this. So we need to find our time, right? So it's asking what will the population be in 2014? Well, if year 0 is 2003, we can subtract 2014 by 2003. And this will give us the years from year 0 till to 2014. So we subtract this as 1, 1, 0, 0. So we see it's 11 years. So our new equation here, so this is the one, all we did this here is to find out our 0.8, which is going to be our rate of change plus our 1, and then our initial value, which was 150. And we found that. So now we can have our a to the time is going to be 11 years is equal to our initial amount, which is 150, times our, we know our rate already is 0.8, and it's going to be to the 11th power. All right, if we put the 0.8 to the 11th power in the calculator, we end up getting it's equal to 150 times 0.085899 ... It continues. I mean, you can just really put 0.086 because this would round up, and then we have to multiply that by 150 now, so we'll put equals. We multiply by 150, and we end up getting 12.8, or we can just say approximately 13. So this is pretty bad, right? Because if we're, going down exponentially, that this is basically saying that. So let's do, if the 2003 to 2004 trend continues, comma, there will be approximately 13, I forgot what they're called, Iberian lynx, Lynx, in the wild in 2014, which is kind of crazy, right? Only 13 left, but I mean, that's just math. I don't actually know if this is true or not, because if that's the case, we're in 2019, so this would probably be like negative, which is terrible for an animal, but it's basically kind of like a recap of what we did. We had to find this information here first. So we had our initial, which is our at year 0, which is the 2003. So we had our initial here at year 0. We found our rate by doing the change of y over y. And then remember, the change of y is y2 minus y1, or the delta y. And then y1 would be the bottom because it's the original. Then we subtracted the y2 minus the y1. I got negative 30 over 150, which gave us a negative 0.2. We plugged that in for the rate and added 1. So 1 plus negative 0.2 would give us a 0.8. We plugged in 0 and we plugged in the initial, what we started off with, and got a is equal to this. So now we can plug it in here. But in order to figure out in 2014, we got to figure out how many years was that, starting from our 0. So we got 2014 minus our 2003 and got 11 years. So it's going to be 8 to the 11 is equal to our initial amount, 150, times 0.8, which is our rate of decay, to the 11th power. Plug it in, simplify, and we got approximately 13 lynxes.